Hey guys, welcome back to another conservation of momentum problem brought to you by Physics in the Flesh. A 22-gram bullet traveling 220 meters per second penetrates a 1.9 kilogram block of wood and emerges cleanly at 168 meters per second. If the block is stationary on a frictionless surface when hit, how fast does it move after the bullet emerges? Okay, so first things first, we're going to start this off by drawing a picture. Remember, with these conservation of momentum problems, you have an initial scenario and a final scenario. Okay, involving usually the same objects, but slightly different things going on. Okay, so here's our first scenario. We've got the block of wood sitting on the stationary frictionless surface, and then we've got the bullet heading toward it. Okay, so here are some streamlines for the bullet, and afterwards, the bullet penetrates the wood and emerges cleanly from the wood. In other words, it doesn't take any extra mass from the wood. Okay, so assume it emerges from this hole. Here's your bullet, and it's going forward, but now your block of wood is also going forward. It also has some momentum forward now. Okay, so let's label our objects here. So the bullet I'm going to call B, the wood W, so WB. Now I'm going to start labeling my knowns and unknowns. Okay, so initial speed of the bullet is 220 meters per second. Mass of the bullet is 0.022 kilograms. Remember, the question gave it to you in grams. Be careful with questions like this because bullets always travel very fast and have a very small weight. Make sure you convert the weight to kilograms and make sure you don't accidentally read this as 22.0. I know you're probably thinking, man, that's really obvious. You don't need to tell us. But trust me, when you start plugging in the numbers, you don't always think about what's logical till you get to the end. But nonetheless, here we go. Mass of the wood, 1.9 kilograms. Initial speed of the wood, 0 meters per second. Just a nice way to organize your work and what you're given in the question. We know that the final speed, V2B, of the bullet is 168 meters per second, and we're told it emerges cleanly. In other words, there's no wood stuck to it, there's no mass that went with it. So the mass of the wood is the same, and we have to find the final speed of the wood. So there we go. And we know we're dealing with conservation of momentum, so we have an initial situation 1 and a final situation 2. And based on these, we're going to create our conservation of momentum expression. So P1 equals P2. Okay. So let's just start filling in everything. Assume everything has momentum in the beginning, everything has momentum in the end. We can always cancel out values after. Okay, so initially we have MB V1B plus MW V1W equals MB V2B plus MW V2W. Okay, so now this is where we can start canceling things out. We know that V1W is 0, right? If this is 0, 0 times anything is 0, so that entire thing disappears. Okay, so in other words, initially we just have the bullet, okay, so 0.022 kilograms times 220 meters per second equals, again, mass of the bullet, 0.022 kilograms times V2 bullet, 168 meters per second, plus 1.9 kilograms for the wood times V2 wood. And that's what we're looking for, right? That's our unknown. So let's solve this, subtract the two numbers, and then divide by 1.9. All right? So if you plug in the left side, you're going to end up with 4.84 kilogram meter per second. Okay, on the right, you're going to get 3.696 kilogram meter per second. And then, of course, plus the 1.9 kilogram V2W. Okay, so 4.84 minus 3.696, so bring that to the left. You're going to get 1.144 kilogram meter per second equals 1.9 kilogram V2W. Divide both sides by 1.9 kilograms, right? So then your kilograms are going to cancel out, and you're going to be left with V2W equals 0.60 meters per second. And there you guys have it. Now, does that answer make sense? Yes. I mean, the bullet's coming out at a small difference compared to what it went in at. 220, it's coming out at 168. It's very, very light. 22 grams compared to 1.9 kilograms. Huge difference. Block of wood is going to be moving but at a very slow speed. So 0.6 makes sense. All right, guys. Be sure to subscribe to Physics in the Flesh if you haven't done so already, and smash that like button if you liked the video and it helped you understand conservation of momentum just a little bit better. All right, guys, I'll see you tomorrow at 12 noon for video 121, Impulse and Collisions 1. Hey guys, that's it for this episode. If you enjoyed it, be sure to check out some of my most recent videos posted over there on the right, which you can click on your screen right now and watch. Other than that, guys, I hope you enjoy the rest of your day, and I will catch you in the next video. Is the end screen too long this time? Wait, you're still recording? No! Oh. Gotta move that chair out of the way now.